So with MnO2 here, we started talking about these types of compounds last week. First off, what type of compound is this? Ion. How do you know it's ionic? Metal and nonmetal, all right? So it's a metal and nonmetal, so we know when we name it with ionic, ide is going to be the end. It could be ate or it could be ite, but when do we see ate or ite? We talked about this on Thursday. When is it ate or ite? Ate or ite? Look back at your notes. Okay, but what do you have there? What type of ionic compound? We have two different types of ionic compounds that we've talked about already in this unit. There's starts with a B. Binary or close. Ternary. What does ternary mean? You have a what? What's present in the compound? Look back at your notes, guys. Flip back. Don't worry about the chart or the table from the homework. Flip back in your notes. What do you have in a ternary compound? We are reviewing what we talked about last week, that long weekend, you know. We loved it, but we're like, oh no, we forgot everything. Okay? Ternary. What do you have in a ternary compound? Okay, a ternary compound has a polyatomic because it's got more than two elements in there. That's when we use ate or ite. If you hear that at the end of it, you know it's a polyatomic ion present in the compound. All right? So this one does not have one. Remember the trick I started teaching you guys? How do we split up the compound to see if we have a polyatomic there or not if we don't recognize it? What's the trick that we started learning last week? Crisscross is writing the formula. All right, so you're there, but when we have the formula, how do we split it up? So draw the line. Where am I going to draw the line here in this compound? After the Mn, right? Because I'm looking for my second capital letter. That's where I split up. What ion comes first? Always. The cation. Then the what comes second? The anion. I don't have a polyatomic ion here because over here it's just one element, so we know it's binary. Okay? But what's unique about our cation, folks? What's unique about this cation?
It has charge.
Right. What type of metal is it? It's a transition metal. There we go. Okay, it's a transition metal. So, like you said, it has more than one charge that it could be. We have to figure out what that charge is. So, Cambria, let me ask you this. Why did you say 2 before?
Because that was one of the charges.
Okay, that's one of the charges that you saw from where? On your periodic table. Absolutely. Okay, so it's one of them that is listed there, but that's not actually going to be the right one here. You want to add to it?
I was going to say.
Okay. So, I was asking you that because I was wondering if you just saw the 2 subscript and that's why you thought maybe it's a +2 or not. If you didn't think that, that's great. All right. We have to figure out what the charge is, guys, and that's what we're going to learn here today. So that worksheet that I passed out, we're going to start there. We're going to come back to the crisscross method. We'll do some more practice, but this is where I want to start today. This looks really complex, but this is what we've got to do. Now, have your periodic tables out if they're not already out. On your tables, you have many of those charges listed there for the polyatomics. Not the polyatomics, the transition metals. All right, when you look at table S, a lot of them have charges already identified for us. You've got to figure it out, and here's the way. If you like math, the formula is going to be the way that's good. That it's probably going to make most sense to you. Some of you, or maybe more visual, you'll start to see the pattern, and that'll work for you. But do not get into what's called the reverse crisscross method. Okay? If you're doing that, I will point it out to you and explain why it's wrong. I'm not even going to teach it to start confusing people. Okay? Go through the math. The math will never steer you wrong. It'll always lead you to the correct charge. Basically, to figure out the transition metal, charge, you've got to see what it's bonded to. That's what's going to dictate the charge on that transition metal. So, we're going to do a little bookkeeping here, and we're going to do a little equation. There's an example problem at the top of your page with antimony 3 sulfate. Okay, so it could be polyatomics in there as well. We're going to go through and we're going to practice identifying all those pieces. Here we go. MnO. Cations. Split your compound up. Where am I drawing my line here with it? After the N, right? So how many cations do I have? I've got 1. Do I know the charge on my cation? No, why not? Because it's a transition metal. So that's going to get the letter X. You're going to solve for X, just like you would in math class. How many anions do I have? 1. What's the charge, guys, on oxygen always? It's a -2, okay? So you probably can see, oh, I know what the charge is going to be, but let's go through and start practicing the equation. Okay? So we've got 1x plus 1 times -2. So we're going to take the number of cations multiplied by its charge. We're going to add it to our anions because what do they all have to equal out to in an ionic compound? All the charges. 0, right? There's no charge on the compound because they've transferred their electrons, so there's not going to be a charge anymore. So it's going to be equal to 0. Now we're just going to go through and solve for x. So we get x minus 2 equals 0. What does x equal? X equals 2. What does that x tell me? Charge of what? The cation, the transition metal. So now I need to incorporate that into my name. How would I name this compound here, guys?
Manganese 2.
Exactly. Manganese 2. Make sure it's a Roman numeral in parentheses, and then it's oxide. Good. Right? Remember, when it comes to ionic naming, we're taking the name of each individual ion and we're just smushing it together. The only way we have to add something to it is if we have a transition metal, and that's our Roman numeral. What does the Roman numeral tell us again? It's charge. I'm going to keep asking that all throughout the day. Now, when you look at this one's a pretty easy one, right? If I only have 1 oxygen and I know the charge, I'm always going to know the charge, guys, of my anion. Jot that down in your notes. You're always going to know the charge of your cation. Sorry, anion. Wow. It's a Monday. You're always going to know the charge of your anion. Whether it's a polyatomic, and you can look it up on the sheet, or if it's a single element, a monatomic ion, you'll figure that out from your periodic table. Remember, we're keeping it simple. Even though anions, when we look at it like in groups 17 and 16, sometimes they have more than one charge there. Like nitrogen's got a bunch. We're keeping it simple and going with the first charge that we see unless we're otherwise told that it's something else. Okay? So when you look at this, if I know, hey, I've got 1 here, and I've got one of those, it has to be a +2. Maybe you can visually see that, and you can kind of reason that in your mind. That's great. That's kind of what we want to get to eventually, move away from the math, but the math will never steer you wrong. Let's take a look at the next one. How many cations do I have in my second example? 3. So I split it right there. Now I have a what in this? Okay, X is my charge, but in this compound, what do I have here?
Phosphate.
We have that was going to be my next question. You stole my thunder. I was going to say, we have a polyatomic. I was going to say, which one? Because you need to know it for tomorrow. PO4 is what?
Phosphate.
Phosphate. All right, good. It's phosphate. So make sure you guys know those 7 for your quiz tomorrow. Anions. How many anions do I have? Here's the tricky question.
6.
How many is it? 2, right? Because remember, I'm looking, guys, at the polyatomic as a whole package. All right, the PO4 is 1 ion. I have 2 phosphate ions. Now, I have more atoms than that, but we're looking at the ion as a whole, the polyatomic ion as a whole. What's the charge on phosphate? -3. Okay, this one is not as easy to do by just balancing out a -2 and a +2. So we got to do a little bit more work. This is where the equation will really come into play. So we've got 3x minus 6 equals 0. Everybody see how I got that? I took 2 times -3. Just kind of skip that first step of plugging it in. How am I going to get x by itself? Add 6. Then divide by 3. What does x equal here? 2. What's the name of this compound? What's the name of it?
Iron 2 phosphate.
Iron 2 phosphate. Absolutely. I want you guys to go through and work the front side of this page, and then we'll go through it together. You always know your anions charged. So when we look at this one, for tin 4 oxide, you have 2 oxygens. Oxygen, you're going to get in the habit, guys, you're going to know that it's a -2 because we're going to use it a ton. Okay, we're going to see oxygen a ton. So whenever you see it, hey, know that its charge is -2. If I have 2 of them, what's the total charge there? It has to be -4. Well, I only have 1 tin to balance that out. How do you balance out a -4? It has to be a +4. That's one way to kind of reason out in your mind if you don't like using the math. Okay, look at your anion and kind of work backwards. That's exactly what we're doing here to solve for X. So that is tin 4 oxide. All right, the next two that you have there. Anybody want to take a stab at Fe2O3? Tony?
Iron 3 oxide.
Yeah, that is iron 3 oxide. Okay, we've got 2 cations, we have 3 anions, -2 charge there. This one's a little bit harder to maybe do it in your head. You know, you've got that -6 charge, so you get the 2x minus 6 equals 0. When you solve for x, x definitely equals 3. Now, this next one is a little bit more of a challenge. This is where drawing your lines to separate out your anions is crucial. Anybody want to take a stab at this name? Graham. Yeah, this is manganese 2 sulfate. The one that can trip you up is if you just automatically look and see oxygen. This one doesn't have parentheses. It's a good habit, guys, to draw your line first. See if you have any polyatomics there. If you see more than 3 elements, you know you have a polyatomic ion. Okay? So as soon as you see that, recognize, hey, there's something here. I'm going to take a little bit slower, and then I'll go through and look at my pieces. So when I draw my line in there, there's my parentheses. SO4. I only have 1 anion. Its charge is -2. I have 1 cation. X, what balances out a -2? It has to be a +2 charge. Flip it over. You guys will do the rest of the back sheet.